The purpose of this video is to give you the answers to the Module 1 assignment. The first question asks how many electrons, protons and neutrons are in one atom of uranium. If we take a look at a periodic table, we can find uranium down here, and you can see that it has an atomic number of 92, which means it has 92 protons. Protons are positively charged, which means it's going to need 92 electrons to balance those out. So the protons and electrons are always going to be equal. This number here is called the mass number. It represents the combination of protons and neutrons in the compound. It's not a whole number because the number, it takes into account all different isotopes of uranium. That is, the kinds of uranium that have the same number of protons but different numbers of neutrons. So what we do is we round this to the nearest whole number, which becomes 238. The way we get the neutrons then, since this is a combination of neutrons and protons, is to take the 238 and subtract out the 92. That will give us the number of neutrons in the nucleus. So the answer to this one, 92 electrons, 92 protons, 146 neutrons. The next one, the isotope of uranium that has one neutron is called, in this case it's deuterium, and the place you'll find this is in the Module 1 soft chalk. Example 4, which outlines the different isotopes of hydrogen that are possible. An isotope is something that has the same number of protons, in this case 1, but different numbers of neutrons, in this case 0, 1 and 2, giving different kinds of hydrogen here, and these are the different isotopes that we can obtain. Which applies to the following. Sodium reacts vigorously with water. This is a chemical change. The reason for this is because sodium reacting vigorously with water, well, first of all, the word reacts is a bit of a giveaway. It tells you that there's a chemical change going on. And also, this is not a reversible process, which means the sodium can't be gained back after it reacts with the water. So this points to it being a chemical change. This is in contrast to the next one. It says a snowflake forms. Now a snowflake is just water. It's just water in solid form, but it's still water. So a snowflake forming from water or water vapor is going to be a physical change. So state changes are generally physical changes. Water is in what state at room temperature? It's a liquid. Distilled, purified, filtered water is considered a compound. Now the reason for this is because it can have a chemical formula written for it, and that is H2O. If it's a mixture, then it's going to be a mixture of compounds or a mixture of compounds and elements. And in this case, water is just water. An element is just something you might find on the periodic table. Fluorine has this many valence electrons. Now the way we can tell how many valence electrons something has is to look at a periodic table that has the groups written above the columns. Now these groups represent the number of valence electrons, or the number of electrons that each of these elements is going to have in its outer shell. In this case, fluorine is in group 7, which means that it has 7 valence electrons, which means that it's going to need one electron to get to its octet. But the important answer here is that it's in group 7. The next two questions. An atom of calcium has 2 valence electrons. The charge on the ion it will most likely form is 2+. And an atom of chlorine has 7 valence electrons. The charge on the ion it will most likely form is 1-. Now I have this one explained over here. If we take a look at calcium and we diagram it out, the way we diagram it out is we can find out what calcium is on the periodic table. It's down here. And you can see that we can use the periodic table to figure out how many rows of electrons there are, or how many electrons there are in each row. So in the first row we're going to have 2 electrons. In the second we're going to have 8. In the third we're going to have 8. And in the fourth we're going to have 2 to get up to calcium here. The diagram then looks like this. So in order to get to its octet, it's not going to gain 6 electrons, it's going to lose these 2. If it does that, calcium has 20 protons, it also has 20 electrons. If we remove 2 of those electrons, we're still going to be left with 20 protons, but now we've only got 18 electrons, which means the net charge on the species is now going to be calcium 2+. So that's how we get the 2+ ion. Now chlorine is over here. It has 2, it has 8, and it has 7. Also it's in group 7, which tells us it's got 7 valence electrons. But it's got 7 down here, which means that if we look at the diagram, it wants to add 1 electron in order to get to Cl-. Now it can do this by adding just 1 electron here. Now chlorine has 17 protons, it also has 17 electrons. If we add 1 electron, it's now going to have 17 protons, but 18 electrons, which means it has a net charge now of Cl-. Now it gains 1 rather than losing 7, because it's easier for it to do that. The last one here, when you draw an atom of chlorine, you have 2 in the first row, 8 in the first row, and you have 2 in the first row, you have 8 in the second row, and 7 in the third row. And again, I've got it here in this diagram. You can see that the reason for that is because when we get it off the periodic table, we do have 2 in the first row, we have 8 in the second, and we count 1, 2, 3, 4, 5, 6, 7 to get to chlorine here in the third row, and that's how we can obtain the number of electrons in each row for chlorine.